Welcome everybody, you're watching Mr. Fugu Data Science. Today we're using RStudio to do label and one-hot encoding for categorical data. As always, the code is in the link in the description below. You'll need to do a few installations of dummies, cat encoder, and matrix. After you finish that, you will need to import the libraries of Markdown, Knitter, Tidyverse, dummies, matrix, and cat encoders. Let's refresh on our data. We have some online sales data that we've been using lately for our online sales data project. Today, our focus will be to create one-hot and label encoding from the country column. Let's get into that label encoding. I will call it country label encode, where we need to first convert our data into a factor, and then you'll need to convert it to numeric. Then we get an idea of what that looks like. Let's make sure that we did this correctly, where we first compare the unique values of the original data to what we just created. So that checks out. Let's do a second example using the cat encoders library, where I will just call it country with an abbreviation basically. So I'll call it label encode 2. And for this one, label encoder dot fit, and then you just call in your data that you used before, and then we will need to transform that data of our country encode 2 that we're creating. You need to also call in a matrix of the data as your other parameter, and then that should be good. And there we go. And that's what we just created above, two different variations. Now let's get into the one-hot encoding. So this one will use a design matrix or a model matrix. So what you need to do is let's call our variable dfcat, where I need a data frame, and I will take the model.matrix, and then you use the tilde, which is this symbol, and then we'll call the rest of our data. And then you need to do -1, because if you don't do the -1, you end up having something goofy happening where you will create a column called intercept. And I'll show you what's going on with that in a minute. Okay, so that should be good. See what this looks like. There we are. Here's our encoded data. Let me show you what it looks like when you don't do that. -1. There you are. It takes away the Australia, and you have this right here. So let's now do a sparse matrix, where I will do sparse matrix encode, where now I'm calling the matrix function from the library we imported called matrix, and then I have to say as dot matrix, and I'm taking in the dfcat that we just created, and then I could say sparse equals false, right? We'll do that real quick so you see what it looks like. That's what it looks like, so let's make it true. And that's our sparse matrix. Then we could look at what the dfcat looks like if I take all the unique values. And I did this so it'll illustrate better for us, instead of having just one column of ones, which is the Australian columns that happen first. So now you can see on the diagonal, these are all of our columns based on country, so that illustrates nicely. We will now notice something here, that when you create a sparse matrix, I mentioned this in a previous video, you'll notice that the amount of memory that's used decreases immensely. Here we are saving 1 order of magnitude, so it's 1,000 times smaller. Okay? And another thing that I would like to say is that when you're dealing with multiple columns of categorical data, it tends to explode in size. So when you're doing any kind of encoding for such as one-hot, this can be an issue. So consider sparse matrices if you can. Now, let's do another example with one-hot encoding, but we're going to use our design matrix once again for a little bit of a different example. So we will create a design mat2 variable, where I will do the model.matrix again, and then I'll use the tilde symbol, where I'll call the country -1, and then call rest of the data. Okay, so do that, and then I can get the head of that. Oh, we need to do something first. I need to create a data frame, so I'll create a data frame from our design 2, where I say data frame of the design matrix 2, call that in, and then I can show the unique values for the head of that so you can get the gist of what it is. So here you go. That's what it looks like as a second example of that. Then let's make sure that everything looks good. So I did this real quick here to make sure that if I didn't check out the unique values of this to make sure it was working, this is another way you can verify that it's actually working. Because if I did not do that, when you print this off without the unique, you'll just see Australia with 1, 1, 1, 1, 1, and then these will all look like 0, so you won't really know unless you do something like this unique, or you take the column sums to know that it's not just one column populating your data and it's working properly as like a safety check. Then I want to use the dummy library form to use one-hot encoding here. So that's pretty cool. I'll create a dummy and then I'll just call it lib encode, where I'm going to bind my columns for these data, take in my country, and then I'm going to call the dummy, which is part of that package, for our data, where we're taking the country, and then I'm using a separator, and it's going to be this underscore. Okay, so then you do that, and then okay, that's fine. Then we'll see what this looks like. Perfect. So we're on the right track once again. Then I can use some one-hot encoding, where we're going to, instead of just print out only the country columns, we're going to have this whole thing appended to our data frame. So let's do this, and there's only one deviation we do, is instead of using country here, we're calling the full data frame. So we'll do those both. Now you notice you have the whole data frame with all the countries that are attached to that. We can also use the cat encoders to also do one-hot encoding, where you first convert your data to a matrix, and then you have to use the transform once again, and you take what you just created and do a matrix of your data, and you could do sparse equals true or false. I just did false here so I could illustrate this. And then as a safety check, I ended up summing the columns so I made sure that it was working properly. And finally, I would like to mention, as a side note, there's a few other libraries you can also use for encoding. And after you do the encoding, you could also do your analysis, depending on what it is. And that would be correlation funnel and ML tools. A few things to be aware of. If you're doing label encoding, you may have issues depending on your analysis with ranking your data. For instance, if you label encoded here and there's 37 countries, you may have issues with your analysis thinking that, you know, country 37 is better, or country 36 is better than 37, or 1 is better than 2, or something like this, right? So you got to be careful with that. Also, there's situations where you can use the label encoding and then further process using one-hot encoding, depending on the circumstance. Now, for one-hot encoding, I mentioned above, but I'm going to say it one more time. You could have memory issues if you're dealing with, for instance, the description column for the items in this sales data isn't like a couple thousand different items sold. So if you made that wide data, you would have issues with memory storing these matrices. So something like label encoding may be useful there. If not, consider the sparse matrices to help save yourself some memory allocation and speed up your processes. As always, I would like to say thank you for watching. I hope this brought utility to somebody. Throw a like and please subscribe, and if you do, turn on that notification bell. Feel free to leave a comment and let me know what I can do better, or if you like this. Have a good one. See you in the next video. Bye.